Hello, everyone. Thanks for joining the APN Digital Summit. We hope you've enjoyed the presentation so far. Before we get started with our presentation, we want to go over a few housekeeping items. First, this session is being recorded. We will send you the recording when the presentation is over, along with the additional information to help you continue learning more about these services. If you do have questions during the presentation, please add them to the question window. We will do our best to answer all the questions as they come in, but if we don't, we will follow up in an email after. If you're having any audio issues, try using your computer's mic and speakers. This usually fixes the problem. Thank you again for your time today. I am now going to pass it over to our presenter.
Hi, everyone. Thanks a lot for joining me today. This is the Serverless Myths Busted session for the APN Digital Summit. My name is Mike Deck. I'm a partner solutions architect focused on our serverless platform. So I work with all of our ISV and consulting partners who are building services and products on top of AWS Lambda and Amazon API Gateway and the rest of the serverless platform in general. If you are doing anything that has to do with those services or building anything related to serverless, I'd love to talk more with you. Feel free to reach out after this summit and let us know what you guys are working on and where we can help. So that's really kind of my job, and would love to talk more about serverless with any of our partners. So to kind of jump into things, this is going to be a discussion of a couple of different myths that we oftentimes hear across the industry, really. And so this is the kind of stuff that comes up both on social media, it comes up in direct kind of customer conversations that we have. And you know, some of the times these may be myths that you yourself have heard and may believe, and hopefully I can help debunk some of those. These also might be cases where your customers are telling you these things. And so hopefully you can use this as kind of a pattern for how to respond to some of those things. If you are working with customers who are thinking about adopting serverless but are scared for one reason or another because they've got some misconceptions, my hope is that this will give you some good content that you can use to talk to them about the truth about serverless. So to get things started, first myth that you know we hear is that serverless is insecure. And I think this is pretty common. Anytime you've got a new set of technologies and people looking to adopt it and people thinking about sort of what the transition is, you know, security is always one of the major points that people want to make sure that, you know, new technologies are in fact secure before they kind of jump in. And when we hear this, though, I think that it's important to really unpack exactly what people mean by quote unquote insecure. And so I think in a lot of cases we see a couple of different things. So sometimes that means, you know, I have an agent that I'm used to installing on all of my hosts, and I can't install that agent anymore when I go serverless. Or it means that, you know, my employees don't actually understand the security features that the serverless platform provides, and they aren't using it. And as a result, we have kind of security vulnerabilities. Or, you know, we aren't good at kind of cleaning up after ourselves and we leave things lying around, and you know, we really need help with what the right patterns are to kind of implement the appropriate sort of cleanup steps. And so I think, you know, anytime that we start talking about security from the perspective of AWS in general, but especially within the context of serverless, it's important to kind of go back to that shared responsibility model that hopefully you all have heard of before. But, you know, in kind of a classic cloud computing AWS model, we talk about this shared responsibility where AWS is responsible for the security of the cloud, and our customers are responsible for security in the cloud. And the sort of line of demarcation as to where that responsibility shift happens is oftentimes, you know, at the guest OS is where we historically have thought about it with service like Amazon EC2, where customers can come in, run their own virtual machines, run their own servers, and get sort of low-level operating system access. That's kind of where we see that line of the shared responsibility model get drawn. When we move to a serverless model, though, a lot of the pieces that have typically been in the customer's control are now shifted down to AWS and are now our responsibility instead of the customer. So this actually gives you sort of both some benefits as well as some things to consider, which is, first of all, now you're not responsible for having to patch operating systems and runtimes and manage the security at that layer anymore. However, that also means that you don't have access to go and install certain tools and things like that that you have historically been used to installing. But I think what's important to understand there is those tools are not really necessary at this point, because you've shifted the responsibility to AWS. So a lot of the concerns and threats that you've been using that type of tooling to mitigate are just no longer relevant in a serverless world, and you actually don't need to worry about that. Instead, what you get to do is focus on your application code, focus on making sure that you're securing the application layer concerns and writing good code. You're importing libraries that are secure. You're not including vulnerabilities from that kind of layer. And so really serverless security ends up being primarily related to that. And I think what's important to understand here too is that there are a number of different sort of features of the platform itself that really help you do a better job with this. So things like access key controls and execution privileges, and as well as automation, or as well as auditing tools that are available within the platform itself now, give you the ability to actually do a much better job of securing your application than you historically have been able to. Because now you get this very sort of fine-grained control and ability to define exactly what permissions are allowed within an individual sort of function's execution boundary. And you have all of these sort of mechanisms now available to actually see the entire audit history of what's been executed and who executed it and how it was invoked. So in addition to sort of the platform layer tools that we talked about, there are a number of other kind of external services that often play into this application security story, in terms of services like parameter store and secrets manager for managing secured credentials, handling encryption of your data in various services like Amazon S3, as well as using things like Cognito and its integration with API gateway to manage kind of the front end authorization and authentication of users to your applications that are integrated with the code that's actually running with Lambda. The other kind of thing to think about is when you're building kind of traditional monolithic applications that just run on top of a fleet of servers that you're responsible for owning, the cloud platform that you're using can really only help at the boundaries of that system. So now you've got kind of this really large blob in the middle that you're completely responsible for handling. There's not really any way for the platform tools and the various security controls that AWS provides at a platform level to help secure the pieces that are inside of that boundary. Whereas when you move to a microservices model and you're deploying things on top of Lambda functions, that gives you now the ability to kind of gain access to all of these various controls and auditing tools and things like that at a much more granular level than you historically have been able to with a monolithic architecture. So one other kind of quick call out, just because I think it's particularly relevant to customers that are building serverless applications, is a new feature that we rolled out just a little while ago called permission boundaries within IAM, which allows you to actually specify now a restrictive policy so that developers or operators who have permission to create new IAM roles and do things like create a role that a Lambda function is going to assume, you can now restrict kind of the level of permission they're allowed to then create for those new IAM principles. So this allows you to make sure that there's no sort of privilege escalation risk in allowing individuals the access to go and create new roles, which is typically something that you have to do when you're deploying serverless applications, because you want to create separate roles for each one of your functions. So there's also a number of other kind of security benefits of the AWS Lambda platform itself. So first of all, function execution contexts are time limited. You're never going to have a server that's sitting out there running for days, months, years on end, which I think oftentimes happens in a lot of customer environments where you set up a server and kind of forget about it, and has it been patched, has it been managed appropriately, and not only that, even if you do have kind of all of the management aspects nailed down well, if an attacker is able to gain access, because the amount of time that these servers run for is relatively unbounded, it gives them a lot more time to sort of exploit any vulnerability that they've been able to find. Whereas with a time-limited service like Lambda, where these servers are not actually around for very long, that really reduces the actual attack surface area that's exposed. Additionally, the operating system and runtime are fully managed within Lambda. So we have a team of security engineers, we have a team of operations experts that are constantly working on raising the bar of the security for our services and how we manage and operate our fleet of compute at scale, and making sure that vulnerabilities are patched and addressed, and that no longer falls on your teams. So customers that were using Lambda when the Spectre and Meltdown vulnerabilities were announced, for instance, they woke up in the morning, they had an email in their inbox that said, hey, there's been this new vulnerability announced. However, for AWS Lambda, there's nothing that you need to do because we've already taken care of it. It's already been patched. And then finally, the kind of fine-grained nature of the security controls that are available. Being able to create a completely separate IAM role and policy for every individual function that you have, not just every individual server, is a really powerful tool that allows you to really practice least privilege at a much finer grain scope than you historically have been able to. Now, with all of that being said, we've talked a lot about the benefits and a lot about the reasons why I think that in many cases serverless applications can actually be more secure than traditionally architected applications. However, that being said, you've got to actually use these features in order to get any benefit from them. So that is definitely true, and that's definitely something I think from a consulting partner perspective that we look to our partners to help evangelize the best practices around serverless security and help customers adopt those best practices, automate them, and really ensure that they're getting all of the benefits of the platform from that perspective. All right, so moving on to the second myth. So the second myth goes a little bit like, serverless is actually really expensive. We hear about all of these stories about people saving a bunch of money, but if you really get up to scale, serverless starts to get way too expensive. And I think if you take a look at kind of a direct cost comparison, when you look at something like a T2 medium EC2 instance, for instance, and kind of normalize that price down to 1 GB of memory. You look at a 3-year RI, it costs $114 to buy essentially 1 GB of continuous compute for 3 years. You then look at running a Lambda function with 1 GB of memory for that same period of time, and all of a sudden you see this massive increase in the actual cost of those CPU cycles directly. And so I think a lot of times people go out and kind of do this math, and they run a spreadsheet, and all of a sudden they start looking at this and think, oh man, serverless is crazy expensive. This definitely is not a good economic model to adopt. But the problem with that is I think that there's a lot of additional pieces to this that these types of relatively unsophisticated models miss. So first of all, there's a number of features that Lambda includes out of the box, such as fault tolerance, queuing and retrying of events. You have unlimited CPUs, so we were looking at T2 type instances in the previous example. You'll never run out of CPU burst credits with a Lambda function. And so as a result, I think, to realistically mimic a lot of these features that customers really want in their own architectures, in a server-based architecture, you're going to need additional resources beyond just a single instance. So if we start to take a look at, what it looks like when we've got multiple instances, so that we can actually spread across availability zones and provide that kind of fault tolerance, and then have a load balancer that we can use to spread load across those instances, and a queue to manage kind of retries there. you end up with a comparison that looks a lot more similar. So, now we're seeing, okay, I've got about 10% surcharge for using Lambda compared to using EC2 instances with the rest of kind of the infrastructure that I'm going to need in order to build this system in a more realistic manner. And that's great. I mean, I think there's a lot of additional kind of benefits from that, and the 10% surcharge for going serverless doesn't seem quite so bad. And I think that there are a number of things that you also have to look at from a savings perspective, such as, again, you don't have any servers to manage. So, the amount of engineering effort that you're going to spend patching operating systems and keeping up with kind of provisioning and managing the servers themselves is much less. And then we also have seen from a number of different customers that they just move faster when they're using serverless technologies because there's fewer things for them to think and worry about. And so they can really focus on just building their business logic and getting out the door quickly. And that's worth something, that there is a real value and monetary value to these kind of things, but that still doesn't really kind of match up with the stories that we hear about customers saving significant amounts of money on their infrastructure by moving to serverless. So I think really, in order to kind of figure out why does it still seem like it's a little bit more expensive to run on Lambda than it does if I were to kind of build this myself, you need to ask the question if the workload itself is uniform. And this is really where Lambda starts to shine from an economic perspective. So there's a lot of different types of waste that we typically see within server-based applications. So one is where you've got sort of this periodic workload where you're getting a batch of requests that are coming in every hour that you have to go and process, and then other than that, the system is sitting relatively idle. And so you've got a lot of kind of wasted capacity that you've provisioned that you're not actually using. Similarly, this sort of high peak to average problem is commonly an issue that we see, because you've got to sort of provision enough compute capacity to handle your peaks, whereas on average your system is sitting at much lower utilization, and so you're wasting capacity and wasting resources in those scenarios. And then the other kind of big piece is when you can't accurately predict your peak, but the opportunity cost of missing out on sort of a large spike in traffic is really costly. This is kind of the Black Friday scenario where your customers, where you're counting on a very large kind of spike in traffic, but it's difficult to predict up front, and the cost of missing out or not being able to serve the traffic that comes is very high. So you end up kind of way over provisioning in order to handle this spike, but then inevitably you always have some amount of buffer that gets wasted. And there are other kind of mechanisms that people use to try to mitigate this. So auto scaling obviously is a major feature that a lot of customers use to save a lot from this waste perspective and make their systems more elastic. But even when you're using auto scaling well, the increments in which you are able to scale are still discrete and can't match the curve of your actual load perfectly. So there's always going to be a little bit of this sort of buffer that exists around the actual utilization. So when we start to take a look at how this utilization impacts the cost model that we were taking a look at, we start to see that when you're using something like AWS Lambda, you're able to your costs scale directly with the amount of work that's being executed by your application. And so now, as you see the utilization of your servers decrease, the cost benefit of a service like Lambda ends up becoming significantly more apparent. And so we start seeing these break-even points where unless you have very, very heavily utilized servers, then the cost savings that you're getting because your Lambda functions are not actually getting executed when they're not needed ends up dominating kind of the cost model. Now, So we talk about this with a lot of customers, and there's always someone that comes back and says, yeah, but my servers are always hot. We've always got kind of really high utilization on our servers. So, that graph that you showed me, I'm way on the left side of that. And so this doesn't apply to me. But that's not actually true. We actually, have looked at this in depth. There are analysts who have done a lot of research on this, and the average enterprise utilization for servers is extremely low. Being even up at 15 or 20% is actually pretty impressive, looking at kind of the long-term average utilization over a long period of time. And so I would encourage you, if this is something that either you're hearing internally or something that you hear from customers, really go and look at the data. Really encourage them to take a look at the metrics that they have. If they're not measuring it, make sure they are measuring it accurately, and then really take a look at that kind of long-term average utilization in order to understand kind of what the current model looks like. So even, then we can talk about kind of auto scaling. So even if you take a look at a system that's being auto scaled really, really well, so within 20% of perfect, the break-even points for when Lambda becomes more cost-effective than using kind of a traditional server architecture is still incredibly high from a utilization perspective, where if you're using burstable T2s, you're going to need to be at least 50% utilization. If you're using C-class instances, it's closer to 90% before all of this kind of breaks even. So apologies, there's some animation problems with this slide. So the bottom line is, kind of the worst case, you're going to get relatively similar infrastructure costs between running a serverless application and a server-based application. Typically, what we see when we look at real customers who have actually gone through these migrations is we see a savings of 4 to 10x in the sort of raw compute costs that they're paying when they move from a traditionally architected system into a serverless. And you can kind of think through, the way to think about calculating this is to really, subtract the safety margin from your server-based costs and then divide by your peak to average ratio. Is kind of the rough estimate for how to kind of think about that. But again, looking at, okay, that's probably a little bit complex to really think about. What do you really expect to see? And it is kind of dependent on workload. So depending on the type of workload that you're seeing is going to impact the cost savings that you should expect to realize. And we typically see when people are doing sort of RESTful API backends for web and mobile applications, you see between a 5 and 10x savings. Streaming applications typically see between a 2 and 5x. And then when you're doing batch processing, that can be anywhere from kind of a break even to a 4x, because that's definitely where you're going to be able to maximize the utilization of any instances that you're running when you aren't having to deal with kind of those peaks and valleys in the amount of requests that are coming in. Now, we talked all about sort of when serverless is a way better deal, when the cost model works really well. There is one scenario in which serverless applications can be more expensive, and sort of the model that we've been discussing breaks down a little bit. You need to do a little bit more careful analysis in order to understand what it looks like, and that's when you've got execution durations that are much lower than 100 milliseconds. So if you've got single-second execution or single-digit millisecond executions happening, then because the billing granularity is 100 milliseconds, you start to see kind of the actual invocation costs, as well as the rest of the compute time starting to dominate that cost equation. So that typically requires you to take a little bit closer look at what the cost model would actually look like. So the question here is, does this really matter? And I think clearly there is a very large amount of spending being dedicated to cloud computing and cloud services in general. And so, being able to take out a significant portion of that cost for your customers or for your own services that you're running internally, I think has a significant impact on the bottom line and for the industry in general, certainly. So, all right. So moving on to our third myth, serverless is just an unzipped library in a container. Why do I need a special service? I could just implement this myself. So I think whenever I hear these types of objections and these types of criticisms, I think it's important to think about, okay, what really is an application from a cloud perspective? If we were to talk to people in 2014, I think an application really comes down to, okay, it's a bunch of code that we have to build and test, and then we sort of throw it over the wall to someone to operate and make sure it runs on top of a fleet of servers. But more and more, the modern answer to that question is an application is really a set of managed services that are orchestrated with custom business logic that's encapsulated into individual microservices or functions. And so I think it's this shift in kind of the definition of what we consider to be an app that is really what makes the difference when it comes to kind of the serverless paradigm in general. So when we look at services, managed services as building blocks within kind of the serverless platform as a whole, there's a lot more than just Lambda here. It's a lot more than just sort of, oh yeah, we've got the service that that I can hand a zip file full of code to and it'll run my code for me. Like, how hard is that? I could do that myself. One, I think there's a lot more to kind of what Lambda is providing that we'll talk about in a second. But two, there's a lot more to serverless than just Lambda. And so it's important to kind of think holistically about this set of managed services that can now be very easily strung together in order to build very kind of rich customer experiences. So, you look at things like a serverless web application where you take Amazon S3 and use that to serve static assets, and then you build an API with API Gateway and Lambda that then persists data into one of our managed database offerings. And now all of a sudden you've got this extremely scalable, highly available web application that really takes very little time to build and significantly fewer resources to operate than a traditional one would be. Or you look at something like a serverless analytics platform, and we have a number of different customers who are now kind of using Lambda to manage all of their streaming data ingest and building data lakes and analytics capabilities on top of services like Amazon Kinesis and using Amazon Athena to do queries against this kind of aggregated data. And again, it's this concept of not how do I write the code and deploy it and actually have code that I've written run, but more how can I take advantage of all of these building blocks that are available to me, stitch them together with my custom business logic and make something that's really really interesting. So we see a number of different patterns starting to emerge in this way. And so, there's a countless number of different types of use cases and different architectures and patterns that we're starting to see that really involve, several of these managed services that are then getting glued together with AWS Lambda functions, where you can implement kind of custom business logic and then have it run on top of this managed environment where you no longer are taking on that full burden of operating the application yourself and kind of managing all of the underlying compute. And in fact, we're starting to look at this and you see sort of this extremely long list of really kind of use cases and various kind of high level functional patterns for addressing a number of different things. And we're even starting to see more kind of meta patterns start to emerge from this, where you may have an asynchronous kind of messaging type application where you need a Lambda function to respond to asynchronously published events, or perhaps it's sort of an inverted model where Lambda is waking up periodically to go and fetch data from a particular service and pulling information that way to go and execute some kind of custom logic on it. Everything from chatbots that are having conversational interfaces to kind of these more complex data-driven applications where you're able to really leverage kind of the scale that Lambda provides you in order to process data at a scale that you weren't able to previously, or that didn't sort of make economic sense. And so more and more we're seeing a shift from applications as this idea of I've got a bunch of code that I need to write and a bunch of individual components that I myself am going to manage, into a how can I now take all of these existing managed services that are very easy to use, they're completely managed for me, and I only pay for them as I actually use them, and then glue all of those components together into kind of useful applications for my customers. So kind of some final thoughts to kind of wrap all of these concepts up on this idea that serverless is really just this unzip library. The real value of serverless is not so much in its ability to execute code, but it's really in the operating model that it's providing you. It's this idea that I can pay per request, I get things in real time, I get highly available fault-tolerant systems without having to do a significant amount of engineering on my side, and then all of that is deployed and managed on top of this massive fleet that's deployed in a multi-tenant way, so that everyone now gets to take advantage of the economies of scale that have historically only been available to a very, very few number of companies. So now, even if you have a relatively small operation, you can take advantage of these larger scale these services that would typically only make sense to kind of operate in managed service fashion for if you were a much larger company. And really, these managed services and how they begin to be stitched together are becoming the new design patterns for modern application development. And so really, yeah, when you start thinking about how to architect new applications, don't think as much about how am I going to build all of this functionality into code that I own and manage myself, but really more about how can I delegate as much of the functionality of this application onto managed services, and what is the truly differentiated business logic and specific functionality that I need to develop that can ride on top of those managed services. All right, so the last myth that we're going to cover today is this idea that you need special tools and processes, and that if you shift over and start using serverless, or you start building applications using serverless architectures, that everything about your organization is going to have to change. You're going to have to retrain all of your developers, and they're going to have to learn all kinds of new tools and everything. And while there's certainly new things to learn, and we certainly see a lot of opportunity for our consulting partners to help customers with their journey to serverless and make sure that they're implementing best practices and understanding kind of where those differences lie, I think oftentimes there's this perception that the differences between the serverless world and traditional application development is very vast. There's only a very small amount of skills and tooling and processes that I'm going to be able to kind of pull over from my traditional model into a serverless development environment. But in actuality, I think the picture looks a little bit more like this, where there's a lot of stuff that does not change when you move into a serverless world. So all of the tools that your developers are using to actually write code, so writing code inside of standard IDEs, using testing frameworks and build tools to actually ensure that your code is getting built and tested appropriately, and that you're keeping a high quality bar for the code quality itself. So not just the tools that you can use to do static analysis against the code, but also just the general programming practices themselves really don't change. I think a lot of times people have this perception that I'm going to have to make significant changes. I'm going to have to relearn everything that I've already learned about how to write object-oriented code or things like that. And I don't think that that's true. I think there are some minor changes to certain types of programming models that don't make sense anymore, and certain best practices that you want to make sure that you're following. But the vast majority of kind of high quality code design and software development practices continue to stay the same regardless of whether you're planning to deploy the application on top of an EC2 instance or whether it's going to be written for Lambda. Additionally, all of the CI/CD pipelining and the tools for automating, the majority of the deployment process for your application stay the same. And then even things like application monitoring. So a lot of the practices that you have around actually understanding what your application is doing at the app layer, not necessarily at the infrastructure layer, but all of those kind of things I think continue to stay the same. Now, one of the things that is certainly true is there are a number of sort of tools and processes and concerns that go away when we're talking about moving to serverless. So one of the big reasons that customers like moving to serverless is that they no longer have to deal with host monitoring. So you don't need a whole suite of tools that you used to just to be able to measure, the CPU utilization and things like that. You no longer need to worry about operating system configuration and host drift and things like that, and how do I roll machine images and how do I kind of manage pipelines from that perspective. So a lot of that stuff goes away. Again, antivirus and some of the other sort of host-based controls from a security perspective are all sort of managed for you now. You don't have to think about that, as well as a number of other kind of infrastructure layer considerations that you're no longer responsible for. Now, there certainly are some things that are serverless specific that you need to think about. So one of the big things that I recommend every customer use is some sort of serverless application framework. And we'll talk a little bit about that in a moment. But there's also sort of some differences around how you sort of approach local testing and debugging that I think oftentimes trip people up. But again, there's more and more tools that are addressing that and helping to make that a more seamless experience today that I think are important to understand what those are and how they work. And then the last piece of that would be sort of runtime security tools. So we talked a little bit in the first myth about kind of that application code, that shift in where the shared responsibility model starts to split. And now, because you are solely responsible for your application, you can actually now use much more targeted tools that have been tailored to work within kind of a serverless environment that actually provide you with a significantly higher level of visibility and control than what you've been able to do previously. But there are some sort of differences, I think, in some of the ways that those tools work. So, kind of looking at one of the first pieces of this list, and really this relates to a number of the other components as well. The AWS Serverless application model is a tool that we have developed and open sourced that allows you to define serverless applications in a concise manner and helps address a number of the kind of differences that we were talking about in terms of providing you with an application framework and a way to define your application and deploy it effectively, as well as doing local testing and debugging within your kind of local environment. So the serverless application model, as I mentioned, provides a kind of simplified application definition format. So this enables you now to define the structure of your application in a much more condensed format, in a declarative mechanism that sort of sits on top of the existing CloudFormation specification, but makes it much more concise to define serverless components and kind of how your application functions as a whole than it would if you had to explicitly define every individual resource explicitly. It's built on top of CloudFormation, so not only do you use the same sort of general syntax of CloudFormation for your templating, but you also use CloudFormation to actually do the deployments themselves and deploy your applications. So this gives you the ability to take advantage of all of the existing features within CloudFormation. So you still get access to change sets, and you still get sort of that atomic execution plan that CloudFormation provides, and if there are problems or errors, you get automated rollback and management from that perspective, and you're now able to sort of manage your applications as CloudFormation stacks very easily. And then the last piece of that is the serverless application model also has a CLI tool that provides you with an easy way to manage kind of local testing and debugging that we'll take a look at as well. So it's also important to note that there are other options out there besides just the AWS SAM framework. So certainly SAM is a fantastic choice for all of the reasons that I just discussed, but there are a number of other kind of partner tools out there that serve similar roles, and in some cases even integrate with SAM to take advantage of some of the local test and debugging tools within the SAM CLI. But certainly serverless, Stackery, Pulumi, and there are a number of other options out there, as well as open source options, are great examples of other kind of frameworks that help make it easier to manage kind of your serverless application in general, how it's defined, how it gets deployed, and make sure that you sort of have a repeatable mechanism for pushing out changes to your application into different environments and kind of promoting builds across that stage. So I think the important thing here is not necessarily which of these tools you choose. That's certainly something that I talk to customers a lot about in terms of when they're making these types of decisions and what are the pros and cons. But I think what's important here is that you do use one of these tools, that you do pick a framework that meets your needs, and not try to kind of roll that on your own, because I do think that is one of those kind of cases where there is a little bit of a change in terms of how does code actually go from my developer's IDE into production. How do I make sure that deployment phase happens effectively? And trying to hand roll and own all of that automation yourself, I think, is oftentimes a mistake that customers make early on when they're adopting serverless. So I definitely highly recommend, if you're not going to use AWS SAM, use one of these other partner tools that are out there, or pick one of the open source options and move forward that way. I think it's also important to talk a little bit about monitoring and how kind of the story around monitoring your application changes when you go from a traditional architecture into a serverless world. So the real difference here, I think, is in the focus of what you're monitoring and how you approach it. So when you have a traditional kind of server-based application, there are a lot of considerations. There are a lot of things that you need to keep tabs on in terms of CPU utilization and disk I/O and various other operating system level statistics that you need to be monitoring and kind of managing. Have an operations team that's responsible for that. When you move to a serverless world, the focus of what is really important to be monitoring shifts. And it's not to say that these things are not important even when you're deploying the servers, but I think oftentimes customers get so wound up in these server-based kind of metrics and having to monitor the infrastructure level concerns that they run out of time and energy to devote to looking at more of these application considerations. And so I think that's one of the big advantages here, is that now you can take all of that time and energy and tooling costs that you used to spend worrying about how your servers are performing, and start to look at things like user metrics and actually tracking the business outcomes that are happening within your application, so that you get deep visibility into the impact that the software that you're running is having on the business itself. And then also being able to understand sort of health from the perspective of a service at a service level, instead of necessarily looking at it at the actual sort of infrastructure or hardware level, like we historically have. So again, being that this is a partner summit, I want to do a shout out quickly to a couple of different partners that we've worked with who have really fantastic kind of serverless support, working with a number of others as well to kind of improve the support for serverless applications and make it easier and easier to integrate their tooling with the AWS Serverless platform. If you feel like you should be on this list, and my apologies if I didn't include absolutely everyone, but if we haven't spoken before and we haven't talked about what you guys are doing, or if you want help with what is the right way to integrate your tool with Lambda and the rest of the serverless platform, and make sure that serverless applications are well served by the products that you have. I'd love to talk to you. Please don't hesitate to reach out, talk to your PDM or PDR, and ask to talk to me, and we can definitely set up a time to discuss the opportunities that are available for your product to integrate better and provide value for our joint customers. So the last kind of subsegment of this, this kind of myth about everything changes is definitely one of the ones that I think where there's probably the most truth to the myth is in terms of debugging and testing locally on my developer workstation changes a lot when I move to a serverless world, and that is true, because basically there's this fundamental difference between kind of a traditional server-based approach where I can run an application, I can launch it with something like Node using the inspect flag, and then from there, now the application process itself is going to be listening on this port that I can connect to from an IDE in order to do remote debugging on the process. And so this is a fantastic feature that pretty much every language runtime has these days, that makes it really easy for you to get really rich kind of step-through debugging capabilities within your IDE when you're interacting with these your service and trying to test and debug it. And the problem is when you move to Lambda and start deploying your application on top of a managed service like this, Lambda doesn't allow any kind of ports, any access to custom ports. So even if your application was listening on a particular port, the Lambda service itself wouldn't allow any external connections to come in. That's part of the security model of Lambda, and actually one of its kind of great features. So this becomes kind of problematic. I can't go and connect to these remote processes the way that I'm used to. So now if I've got a bug that I can't deal with just with logging, or I really want to be able to kind of single step through, that becomes challenging. However, there's now, as part of the SAM CLI that we discussed previously, and this is also available in some of the other frameworks that we talked about, some of the other partner tools, there's a way that you can now run your Lambda code locally on your own local environment inside of a Docker container, basically, that's managed by the SAM CLI. And now you can get this very rich kind of debug workflow locally, where I can go write and edit code through my standard IDE. This all stays kind of just locally on my laptop's hard drive. I then launch the SAM CLI to say I want to run my API or my Lambda functions using the SAM CLI local invocation model. And then I can have SAM spin up my API, for instance, and then I can use any client I want, whether that's a browser or some other emulated mobile application or something like that, to go and make requests into this now managed kind of container that's running locally. And because this is just now running locally in a Docker container on my own laptop, my IDE has the ability now to go and connect over a standard debug port and connect to that application and do all of the standard kind of debugging process that you would expect to be able to do in any other kind of language runtime. So again, while the tooling itself that you use in order to achieve kind of this local test and debug process changes a little bit, so you're introducing the SAM CLI or some other application framework in order to enable this. I think the overall developer experience and kind of capabilities of the platform is largely unchanged, kind of moving from a traditional world into a serverless world, as long as you have the right kind of tool. So those are all the myths that I wanted to talk about today. Hopefully we've successfully busted them in your mind, and you've got a few new talking points that you can use to talk to your own customers about their perceptions of running serverless applications and why it makes a lot of sense to do so. So really appreciate your time today, and thank you very much.